So let's get going on today's class. So today we're going to finish up the last of what we need to take a look at to get ourselves ready for the upcoming exam number 3. So we're going to wrap up our look at t-tests today by basically revisiting all 3 t-tests and discovering, number 1, when or how do you decide which one of those is the right t-test for any particular situation? And then 2, why that determination is so vitally important. So that's what we're going to be taking a look at today. But before we get to that, just a brief reminder that exam 3 is coming up in a week. So it's going to be on Tuesday, April 9th in class. It's going to cover chapters 6, 8, and 9. So chapter 6 was the chapter on the determining the comparison distribution. 8 and 9 were the 2 chapters on the t-test. And as before, it's going to be a computational exam, so it'll be available through Canvas. There's going to be 8 questions, and this one will also be open book, meaning open everything except communication with other people. So once again, we have a bunch of things to do on this particular exam. It's going to be all hypothesis testing. So you are going to be doing your 3 t-tests to analyze various experimental data. And that is the extent of it. So chapter 6 will be tested to the degree that you can properly interpret the comparison distribution that SPSS will give you. So that's where chapter 6 is going to factor into it. But it's all going to be about hypothesis testing. So we have 3 tests to do. So whatever resources you need to let you know how to identify that test, how to set up the data, how to conduct a test, and then finally, importantly, how to interpret the output, where to look. Make sure that you have those resources. Feel free to use those. And let's see how many perfect exams we can get this time. So just to kind of let you know what your what it'll look like, I did upload a template questions. These are example questions of what you're going to be seeing. So this is what your exam is going to look like. So you will, it'll be a little bit more detailed information than blah, blah, blah. But anyways, you will have a description of the experiment. You will be told whether to do a one-tailed or a two-tailed test. So for example, much like in the previous hypothesis testing questions on exam 2, it says there right at the end, use a two-tailed test with an alpha of 0.05. So you'll be given that information. You'll be given your raw scores. You will have to format those for SPSS, enter it into SPSS, run the correct t-test, and then you will have to fill in what is the null hypothesis, what is the research hypothesis, the degrees of freedom for your comparison distribution, the standard error for your comparison distribution. I will not be asking for the mean of the comparison distribution because the mean is either 0 or your hypothesized mean, so that will not be asked on the exam. Your cutoff probability, which is your alpha level. This is my early Christmas gift to you, super early this semester. I just want you to identify what alpha is. Do not second guess yourself. Do not do anything weird with alpha, like divided by 2. All I want to know is, could you find where alpha is in that question? It's going to be the last sentence. Pop it in there. That's your comparison probability. You got to figure out in SPSS, what your samples probability is, that p-value. Is it a two-tailed or is it a one-tailed? Two-tailed, read it directly. One-tailed, cut it in 2. And then finally, whether you accept or reject the null and the research hypotheses.
Tuesday, right?
Yeah. Okay. Yep. So a week from today. All right. So you will have questions where you get the descriptions. Here's another example here where you get the descriptions and the scores. And in this case, I'm giving you the hypothesized mean. For the one sample t-test, you will have to figure out the hypothesized mean. And then again, just fill in all the information for all 5 steps, make your final determination, and that is going to be what the entire exam is going to look like. All right, so that is what you can expect. And we are going to have a review session. So the exam is in a week. Review session is going to be next class. That's going to be Thursday, April 4th. Once again, as before, it's going to be that open review session where it's completely student driven. So if you have any questions, if you have anything that you want to see another example of, if you have whatever you need to get prepared for exam 3, I will be here to help you during that time. But also, it's completely optional. So if you feel you can better prepare on your own during that hour and 15 minutes, feel free, but I will be here for anybody that wants to show up and go through that review session. All right, so any questions on exam 3 before we start up today's class? Yep. For exam 3, you can try the questions on the template. And then also the exam 3 is going to look exactly like the in-class demos that we've gone through so far. So the extra practice that you had on each of the demos from the 2 from chapter 8 and the 1 from chapter 9, you can use those as practice as well. All right, so what we're going to be doing today, we're going to be doing the last little bit of information that you need for t-tests in order to actually be able to do the t-tests in real life. So we've gone through the 3 major types of t-tests, and so far it's been pretty easy to decide which t-test we needed to do because when we were in chapter 8, part 1, we were doing 1 sample t-test. And we were doing those because we were in chapter 8, part 1, and it was telling us to do 1 sample t-test. However, in the real world, like when Harlow was doing his experiment, they needed to decide, the correct test for this particular situation is the 1 sample t-test. So what we're going to be doing today is we're going to see the steps that psychologists use to analyze the situation, analyze that study on timeout and whether it's effective for adults or not, so that you can make the determination that the correct t-test for that would be the dependent means t-test, and also analyze the study about Loftus and Palmer's study on memory, where they analyzed the estimated speeds of subjects that were asked how fast were the cars going when they hit each other versus how fast were the cars going when they smashed into each other. They weren't in a particular chapter of their textbook, so how did they determine that they needed to do an independent means t-test? That's what we're going to be doing today. So this is all part of your training to become those psychological ninjas that can handle any data that comes their way. So you are ready, you have the complete tools in order to do a hypothesis test correctly. And now we're going to give you that last little bit of training that you need, because now you must choose which one is the correct one to do. And again, this is what we do in the real world. All right, so again, we're going to start off with your general guide for choosing hypothesis tests. And then we're going to take a look at the importance of choosing the correct test by running the same data in a dependent means t-test and as an independent means t-test. And we're going to see that we get wildly different results depending upon which test we choose. And then I'll mention the homework assignment, a couple of special dates coming up because that exam is going to be on Tuesday. Just want to make you aware of those. All right, general guide for choosing a hypothesis test. There's a number of different ways to get to the correct hypothesis test. This is one way. This is the one that I like to use. So we'll go over, first off, in general. So in general, whenever you're approaching an experimental situation, the correct hypothesis test completely is dependent upon the experimental situation, the experimental characteristics. So all you need to consider is how is the experiment structured. And one of the first things that we ask is how many independent variables are there? So how many causes are there in this particular experiment? If there are 2 or more independent variables, that's actually outside the scope of this course. So I mention that because occasionally students, actually not occasionally, very often students will include 2 or more independent variables in their advanced lab. So I have students right now who are doing their advanced lab, and they have 2, 3 independent variables. And I just want you to be aware that we are not covering that in this course. Introductory psychology courses typically don't have that. So if this is you in your advanced lab and you have 2 or more independent variables, feel free to knock on my door and say, you know, I know we didn't cover this, and I will be more than happy to show you how to run that particular test. But just be aware of that. I'm trying to avoid the knocks on the door where the students apologetically tell me that they forgot how to do this, and I have to explain, well, we never actually covered that. So feel free to knock on my door if you have 2 or more independent variables. We've only ever been dealing with one independent variable, right? So one variable, type of mother. Is it fur, terry cloth, or is it wire? We have one variable, type of question, hit or smashed into. We have one variable, duration of timeout, 10 seconds or 5 seconds. So we're only ever dealing with one variable. So in the real world, you figure out you have one variable. The next question you ask is, how many levels do you have? A level for a variable is how many different values can that variable take. So the answer to that, how many levels, you can split it up in 2 categories. If you have 3 or more, then you have to do what's called an ANOVA, and that's coming soon. That's going to be the last chapter that we cover in this course, how to deal with experiments where you have 3 or more levels. So if you are doing an experiment and you're looking at the attentional abilities of children, of young adults, and of elderly adults, you have 3 levels, and you're going to need to run an ANOVA. So far, however, we have only been dealing with 2 levels for our independent variables, right? So there was only 2 types of mothers for the monkey. There was the wire mesh, or there was the terry cloth. There was only 2 types of questions, smashed into or hit. There's only 2 types of timeout durations, 5 seconds or 10 seconds. And if you have 2 levels, then you're doing a t-test. So this is going to be where you can start for the exam. So for the exam number 3, we know we're doing a t-test. So this branching section is where you can start for exam number 3. All right, so we know we're doing a t-test. What's the next thing that we got to ask? We got to figure out which of the 3 t-tests are we doing. So what I like to do, and again, you can do this in various different orders. First thing I like to ask myself is, how many times is each subject measured? That's the first key thing to narrow down which test that you're doing. So you ask yourself, and you'll read this in the description, how many times is each individual subject measured? And they're either going to be measured once or they're going to be measured twice. It's either going to say we measured them one time, we measured their ability to do this, or they're going to say we measured their ability to do this in the morning, and then we measured it again in the evening. We measured it under this condition, and then we measured it under this condition as well. We measured it under 5-second timeout durations, and we measured their accuracy under 10-second timeout durations. If you have a subject or your subjects being measured twice in your experiment, well, then you have a dependent means t-test, and you are done. Your decision is made. So as soon as you read that your individual subjects were measured twice, it's a dependent means t-test, and we're done. If, on the other hand, they're only measured the one time, they're only measured once during the experiment, well, then you have to ask yourself, how many different samples are there? How many different groups of subjects have been treated differently in the experiment? All right, so we're asking how many samples there are. If there is only one sample, if everybody in the experiment got treated the same, such as every monkey got treated the same and had access to either the wire mesh or the terry cloth mother, if that's the case, then you have a single sample t-test and you're done. You've made your decision. If, on the other hand, there are 2 distinct samples, 2 groups of subjects that have been treated differently, right? So we have one group that took the drug, one group that took the placebo. We have one group that, completed the English test, one group that completed the math test. We had one group that was asked how fast were the cars going when they hit each other. Another group was asked how fast were the cars going when they smashed into each other. 2 separate groups, 2 separate samples. That is an independent means t-test. And once you get there, you have made your decision. So that's the decision tree that you can use. There it is in total. And remember that we are going to start for the exam. In real life, you would start up here. But for the exam, you can start right there because we know we're going to be doing t-tests. That's what we've been doing this whole time. And again, you can ask yourself those two questions. How many times is each subject measured? If they're measured twice, you got yourself a dependent means t-test. If they're only measured once, you got to ask yourself one more question. How many distinct or separate samples are there? If all the subjects got treated the same, single sample t-test. If there are two distinct groups of subjects, one treated one way, one treated the other way, you got yourself an independent means t-test, and that's how you make those particular decisions. All right, any questions on how to navigate that decision tree? All righty. So what we're going to do right now is we're going to take a look at a demo problem to take a look at the importance of doing a dependent means or correctly identifying the test that you want to do. So it is absolutely not the case that either test will do. It's absolutely not the case that you will come to the correct decision if you choose the incorrect test. So we'll see a dramatic example of this when we take a look at the following problem. All right, so here's the description. I'll read it out. It goes, people often forget names but believe they never forget a face. Is memory better for faces than for names? A researcher tests 34 subjects. Half of the subjects are asked to memorize a series of 30 faces. Later, they are tested with a recognition task for the faces. The other half of the subjects are asked to memorize a series of 30 names. Later, they are tested with a recognition task for the names. There's the subject scores. So subject number 1 for the faces in the face group scores 69.1%. Subject number 5 scores 76.8%. Subject number 17 got all of the faces correct, scored 100% on accuracy. And then in the name condition, subject number 1, 69%. Subject number 5, 76.2%. Subject number 17 in the name condition, 94.1%. So that's the data. And the first thing we got to do in this, where we want to test whether it indicates a significant difference, we're going to use a one-tail test with an alpha of 0.05. We want to know if faces have better memory than names. The first thing we need to do is we need to identify which test do we need to do. So right off the bat, we can ask ourselves, how many times are each subject measured? And what we find is that we have half of the subjects, they're asked to memorize faces, and later they are tested with a recognition for those faces. The other half are asked to memorize names, and they're later measured for a test of those names. So all of the subjects are only ever measured once. They're only ever tested one time for their memory. So we have to then ask how many distinct groups are there. And as you can just see, we have one group that memorized faces, one group that memorized names. And if you follow the decision tree, that brings us down to an independent means t-test. So in this case, because of the structure of the experiment, we end up with an independent means t-test, and that is the correct test to do. So let's see what that independent means t-test says when we run our one-tailed test with an alpha of 0.05. All right, so once again, same 5 steps. And this is also one of the reasons why you need to correctly identify which t-test you're doing, because it's the same 5 steps for all 3 different t-tests, and SPSS will allow you to plow through with the wrong t-test, and there's nothing in the steps that'll help you identify. So always make that identification first. This one is an independent means t-test, so now we know that we can continue on with our test. So number 1, restate the question as a research hypothesis and a null hypothesis about the population. We want to know, do people have better memory for faces than for names? We're doing that one-tailed test. So the research hypothesis, remember in a one-tailed test, always easier to start with the research hypothesis. So the research hypothesis is that memory is better for faces, and we have our mean accuracy for faces is going to be greater than our mean accuracy for names. So that is our research hypothesis, that the mean accuracy memory for faces is going to be greater than the mean accuracy for names. The null hypothesis is a complete opposite of the research hypothesis. So the null hypothesis is that memory is not better for faces, and that is written as the memory accuracy for faces is going to be less than or equal to the memory for names. So we got our research hypothesis, we got our null hypothesis, so now we're on to step 2. Step 2, determine the characteristics of the comparison distribution. SPSS will do this for us. So I'll just start a start writing some of these down. So we're going to need the degrees of freedom, and we're going to need the estimated standard error for step 2, but SPSS will do that for us. We're going to have to set a cutoff probability. That cutoff probability is equal to alpha. So on your exam, once again, do not second guess yourself. Take a look at this and recognize it as the early Christmas gift that it is. I'm going to ask you what your alpha is. You're going to take a look at what I said it was in the question, and you're just going to transfer that down to that yellow answer cell. We're doing this because it's important to know what is your cutoff probability. It is alpha. So again, this is designed to be easy. And I might be mentioning this a little bit too much, but it just hurts when I see students divide this by 2. You do not divide this by 2. You don't do anything. And I know that they second guess themselves because they think to themselves, you couldn't possibly be asking me to just look at 0.05 and write 0.05. That doesn't seem hard enough. Merry Christmas, right? So make sure you do that. That's your cutoff probability. Determine your sample score on the comparison distribution. Remember that we are changing this now to determine your sample's probability on the comparison distribution. So that is the p-value, and SPSS will do that as well. And then finally, we're going to make our decision, and I'm going to write that one up here for the first time because we got to know whether we accept or reject the null hypothesis. So right now we're going to go into SPSS. So once again, if you haven't already, open up that Excel sheet for Chapter 9, the t-test for independent means, and we will take that up as we go along. So let me get my SPSS up and running here. Not MATLAB. Thought I still had it open. All right, let me just get this going. All right, so while that's starting up, we have our Excel sheet. So the one you're looking for is this one right here. So let me just zoom in on that data right there. So once again, to use SPSS, you must have the raw scores. So here are those raw scores here. And remember that this is 17 subjects who got asked, who got shown faces, and then were tested on face memory, and a separate 17 subjects who got asked about names and then were tested on names. So we got to format this into SPSS so that it is properly formatted for that independent means t-test. So the first thing we're going to do is we're going to take those face memory scores, and we're going to copy it. And this is what I was trying to explain last time. If you are running this and you're running it in your browser, as some of you would be doing, this little multiple line thing up here, this is where you can click on that Citrix receiver. You go here to open clipboard. You can copy your data to the clipboard so you can see that I have all of those scores. And then once you copy it to the clipboard, for some magical reason, you can then copy it to SPSS. So it's just this one little extra step that you need to do, but you can then copy and paste it directly into SPSS. So here is the variable 00001, horrible name. We're going to change that. And what did I call that? We can just call that accuracy. C-C-U-R-A-C. Why? We're good. We're 8 or less. So we'll call that accuracy. And then for this one here, we need to tell SPSS what group these scores belong to. So for this one, we can just call that face. And we can copy and paste that all the way down. And then we don't want to have that as var 00002. So we're going to go back to variable view, and we're going to call that, let's just call that group so we know which group they're in. All right, so now we have the accuracy for the subjects that were in the face condition. Next thing we got to do is we got to take the accuracy for the subjects, the different subjects that are in the name condition. And once again, we need to make that decision, where in SPSS does this go? So we go to SPSS, copied and pasted it out of Excel. Once again, we need to pop that into our clipboard. And once it's in the clipboard, it's ready to go into SPSS. And we really have two possibilities. Only one of them is right. We could pop it up here. So we have column 3 for the name accuracies and column 4 maybe for the identification of the group. However, that violates SPSS's rule that each subject gets one column, and that column is reserved specifically for that subject. So we have rows 1 through 17 being taken up for the 17 subjects in the face condition. We have to put our name scores in the next 17 columns down here, because again, those are 17 new subjects. They all get their own rows. And then to help SPSS identify those, we identify those as being part of the name group. And now we have our data fully entered, fully ready to go, fully transferred from our Excel. All right, does everybody have their data in at this point? Okay, so now that we have it all set up, all ready to go, some of you might have done this already. We have to tell Excel what to do, what to run. So we go up here to analyze. We go down here to compare means. So all of our t-tests very nicely in SPSS, all collected in that compare means dialog box or folder drop-down menu. And then we've already decided we're doing that independent samples t-test. So we click on, independent means t-test. So that is called the independent samples t-test. We click on that, and our test variables, that is your raw scores. Those are the scores you measured off of your subject. So that is the accuracy in this case. So we highlight accuracy, we pop that into test variables. And notice that because group is a string variable, because group is a series of words, you actually cannot enter it in as a test variable. String variables are not allowed in that list. So this is a nice way of SPSS being very friendly to you. You actually cannot put the wrong data in there. Test variables need to be your raw scores. They need to be numbers. So the only other thing that's left is these grouping variables down here. So we click on group, pop it into that grouping variable using that arrow key. And SPSS will then ask us, all right, you told us you have groups. I know this is a t-test, so we're going to have 2 groups. What are they? And then we just have to go here to define the groups. And group number 1 here we'll call face. And group number 2 here we'll call name. And then that lets SPSS know what those groups are. We hit continue, and we are ready to go. So once we have that all set up, once we have that all ready to go, we just hit OK. And there is our output. All right. So there's the output right there. So let's take a look. Let's analyze that output. So this should be what your output basically looked like. And let's take a look at where the information is in that output so that we can fill in steps 2, 3, and 4 now and make that decision for step 5. So we need to decide whether or not to reject the null hypothesis. We have our alpha value right here. We need our p-value. And if our p-value is less than our alpha, we're going to accept our research hypothesis. We're going to reject the null hypothesis. If, on the other hand, that p-value is greater than our alpha value, then we're going to accept the null hypothesis and we're going to reject the research hypothesis. So we got to find out all that information. So let's zoom in on that output there. So once again, make sure you're getting into this habit. Make sure you're double checking yourself. We need to make sure that we've entered in this data correctly. And especially on the independent means t-test where you have to copy and paste all of those group identifiers, it is so easy to copy and paste one too many or one too few. So always check on these group statistics. You can see we got face there, we got name right there. Always check that you got the right number in each group. So we had 17 in the face condition, we got 17 in the name condition. SPSS is telling us, I found 17 in the face, I found 17 in the name. There's the mean that SPSS collected for that data as well. Once again, double check that against your mean in Excel. And very quickly, you can see that the means are the same, meaning that we've entered in our data correctly. So that's always a nice way to just kind of boost your confidence that you can go forward and interpret your data. Because, the first thing is you got to enter in your data correctly. So you always want to just do that double check, make sure that your data got entered in there, that you didn't introduce human error to this t-test. All right, so the next thing, we check the independent samples t-test, independent means t-test table down there. Remember that we are camping out on that first row. So the second row you'll learn about in grad school. First row is where we are right now. And in all honesty, about 95% of independent means t-tests stay on that first row. So we're going to be on that first row, equal variance is assumed. So we need to find characteristics of the comparison distribution, our degrees of freedom, and our estimated standard error. Degrees of freedom, very nicely right there. So we got 32 degrees of freedom. And we need our estimated standard error. So definitely know where to look for this because we got standard error up there, we got standard error up there, we got standard error down here. We want that one down there. So standard error of the mean, 3.034. So we enter that in as well. All right, we got step 2 taken care of. Step 3 down here, this is your cutoff probability, your alpha level. SPSS will not give that to you. That is given to you in the question. But what is given to us and what we need is that p-value, that probability. So for your homework, again, when you're doing this, it will ask you for your t-statistic, just in case you want to know where that comes from. That's the mean difference between the two groups. That divided by your standard error gives you that t-statistic. So SPSS just calculates that for you automatically. And then based on that t-statistic, it figures out the probability that we have two-tailed of getting a t-statistic that extreme if the null hypothesis was correct. That's what that p-value is. And as it turns out, the probability is 0.388. So it's 0.388 is our probability. So we can read that off of SPSS, but then we have to remember that we did not want a two-tail test. We wanted a one-tail test. So the last thing we got to do is we got to take that p-value and we got to divide it by 2. Because this is the probability, this is the proportion in 2 tails. We only want the proportion in 1 tail. So we got to chop that in half, and that's actually going to give us the probability of 0.194. 0.194, that's our p-value for this particular test. So now we got to know, what do we do with our null hypothesis? Are we accepting or are we rejecting? So we go back to our decision slides, and it goes, if the p-value is less than alpha, we're going to accept the research hypothesis, reject that null hypothesis. We have a p-value of 0.194. We got an alpha of 0.05. P-value is greater than our alpha, so we're definitely not going to do this. If the p-value is greater than alpha, we accept the null hypothesis and reject the research hypothesis. So that is what we're going to do. We're going to accept that null hypothesis. And again, it comes from the fact that our p-value was 0.388. chop that in half because it's a two-tailed test, so we got to get rid of one of those tails. That is still greater than alpha, so we accept the null hypothesis. So this data run as an independent means t-test gives us the result where we accept that null hypothesis, and we conclude counterintuitively that people are not actually better at remembering faces than they are at remembering names. So this actually happens a lot in psychology, where there will be some sort of common sense wisdom. There'll be some sort of folk knowledge that is out in society. And a psychologist will run that as an experiment, and as it turns out, it's not actually the case. So this would be an example where that would not be the case. You think we're better at faces than we are at names, but in actuality, this data in this test tells us that we're actually not better. There's no difference in remembering faces than remembering names. All right. So that was the independent means t-test. So far, so good? All right, one moment. All right, so that was the independent t-test with independent means. So now we're going to do another demo another t-test. And what we're going to do is we're going to take a look at the exact same data. So this is the exact same raw scores, the exact same numbers. But what would happen if they came from a different experiment? Specifically, what if they came from this experiment? So once again, people often forget names but believe they never forget a face. Is memory better for faces than for names? A researcher tests 17 subjects. The subjects are asked to memorize a series of 30 faces. Later, they are tested with a recognition task for the faces. The same subjects are also asked to memorize a series of 30 names. Later, they are tested with a recognition task for the names. So notice it's a completely different experiment. Instead of having 34 subjects that we split into two groups, now we have 17 subjects. And these 17 subjects are measured twice. We show them 30 names, and then later we test them on those 30 names. That's one measure. We then show them 30 faces, and later they're tested on 30 faces. That's them being measured twice. So they're measured once for faces, once for names. Same subjects measured twice. That is a dependent means t-test. So by reading this description, we can determine that these 17 subjects have been measured twice. Once you know that a subject has been measured twice, that is a dependent means t-test. So there are the scores, and notice they're the exact same scores that we used for the previous example. So in this case, once again, subject number 1 scored 69.1% for their face memory. The only difference is now subject number 1 in the name group here is the same subject. So this was subject number 1 when they were tested on face memory. And then that same subject also scored 69.1% when they were tested for name memory. Subject number 17 scored 100% on face memory, and that same subject scored 94% on name memory. So we got 17 subjects measured twice. We still want to know if the data indicates a significant difference. We're still going to use a one-tailed test with an alpha of 0.05. So let's set that one up right now. We have our dependent means t-test, and we need to have our degrees of freedom. We need our estimated standard error. We need our cutoff probability, which again is our alpha. We need to have our p-value, which we will look up. And then finally, we need to decide what we're going to do with that null hypothesis. Are we going to accept it, or are we going to reject it? So let's see what we should do. All right, so we start off, once again, restate the question as a research hypothesis and a null hypothesis about the population. Very nicely, this is not going to change. So this is one of those steps where it will not change depending upon the test that you're doing. So that's kind of nice because you can answer the same question with a variety of different experimental structures. So you still want to know, do people have better memory for faces than for names? So this is still the research hypothesis, being that memory is better for faces. So we have that one-tailed test where the mean accuracy for faces is greater than the mean accuracy for names. We need to do the null hypothesis as well. Same null hypothesis, complete opposite of the research hypothesis. So the research hypothesis is that the memory for faces is greater than the memory for names. Null hypothesis is that the memory for faces is less than or equal to the memory for names. Covers all possibilities between those two, which is how a correct set of hypotheses is done. Notice the exact same one that we had before, the exact same as the independent means t-test. So where do things start getting different? Things will start getting different when we take a look at the comparison distribution. So SPSS will calculate this out for us. Things actually stay the same for the cutoff probability. So we're still using an alpha level of 0.05. That's still our cutoff probability. That hasn't changed. Things are going to get very different when we determine our sample's probability on the comparison distribution, our p-value, and SPSS will do that as well. So let's go back to SPSS, and once again, we'll use the exact same data, and we need to set it up this time so that we do a dependent means t-test. All right, so one thing that I typically do when I'm doing multiple tests in a row, for example, like if you're doing an exam, what I find is that if I keep building these up, column after column after column, it accumulates and it makes your later hypothesis test more difficult because you got to determine which columns contain the variables that you want. So typically what I'll do is I'll just click on the column and just delete the entire column. Just get rid of it. We're done with the test. We're done with that particular analysis. So I like to start fresh. So now we have to once again take our face scores and take our name scores and copy and paste those into SPSS. So once again, we copy, we open up our clipboard if you're doing this in your browser. We paste that, and then we go to SPSS and we can paste it there. So now we have our accuracy for faces in our first column, and we go to variable view down here, and let's call that face, so that we remember that is for face accuracy. Okay, so we have our 17 scores for the accuracy for faces. Next thing we got to do is we got to take our 17 scores for the accuracy for remembering names. And we need to decide, where does this go in SPSS? So where are we going to put this in SPSS? Well, once again, the guiding factor is that each subject gets one and only one row. Each subject has a row dedicated to them. So we have the scores for the faces from row 1 to 17, and then we measured those exact same subjects for their accuracy for names. So we have to put these scores in the same row. We have to put them in row 1 to 17, and the only place to do that is to stick them in column number 2. So now we have each subject being measured twice. Subject 2 has 2 scores. They're both on row 2. Subject 9 has 2 scores. They're both on row 9. Subject 16 has 2 scores. Both on 16. So again, remember that principle. Every single row is a single subject. That'll help you format this many, many times. Last thing we need to do is we need to change that to name. All right, and we come back to the data view. We got face, we got name. We're ready to go. All right, so we have that all ready to go. We know we're doing a dependent means t-test, so we go to compare means. We go to paired samples t-test. So again, make that note. It's not called dependent samples, not called dependent means. It's called paired samples t-test. We pop that in, and I believe it's variable 2 minus variable 1. Let's see if I can get this right. So it's variable 2 minus variable 1. We want to know if faces are greater than names. So let's pop name into variable 1. And let's pop face into variable 2. So we highlight them. We click the arrow keys. That'll pop them into variable 1, variable 2. This should give us the memory for faces minus the memory for names. And if faces are better, it'll give us a positive difference. So let's see if I got that right. We'll hit OK here. And I got it wrong. Okay, so this is one of those examples that I was telling you about. I did it my best. I haven't, memorized this yet. But notice SPSS has said for the paired samples t-test right there that it did name minus face. Name minus face means that if face is better, that difference will be negative. So better recognition of faces is a negative difference. I don't want to do those mental gymnastics. That's too much for me right now. So what I'm going to do is I'm just going to go back to my data set. And I'm going to say, you know what? Wrong way. Did it backwards. So I'm going to go back to paired samples t-test. I'm going to highlight those differences, those two variables. And I'm going to use this little directional, multi-directional arrow. I'm just going to click it once. It swaps faces for names. I hit OK. And now, very nicely, I got memory for faces minus memory for names. So if memory is better for faces, accuracy will be bigger for faces than for names. This difference should be positive. Better equals positive makes more sense to my human brain, so we're going to deal with that one. That's our output. All right, so we have our output. We're all done with that SPSS. Now we got to interpret it so we can figure out what we're going to do for step 5. So once again, if the p-value is less than alpha, we accept the research hypothesis, we reject that null hypothesis. If, on the other hand, that p-value is greater than alpha, we accept the null hypothesis and we reject the research hypothesis. So there's our output right there, so let's zoom in. Once again, check that top table to make sure that you entered in your data correctly. So once again, SPSS very nicely says, here's your means for the face group, here's your means for the name group. Make sure that those correspond to the means that you have in Excel. This is the number of subjects in each group. We got 17 subjects in the face group. We got the same 17 subjects in the name group, so we got that as well. This second table down here, completely ignore it. We will not be using the second table at all. SPSS gives that as an output, but know enough to just know that you need to ignore that. We got to go down to that paired samples test table right down here. So once again, we have to start figuring out our comparison distribution. So we have a standard error of the mean. So once again, know where to look. There's a few things that are labeled with standard error, but that's the standard error of the mean that we want. So we got 0.546. And notice this is the first difference. Right, 0.546 for the dependent means, estimated standard error, 3.034 for the independent means t-test. So immediately we've gone off the rails. Immediately it's different numbers. Degrees of freedom is next. Degrees of freedom is right there. We only got 16 degrees of freedom. We got half the degrees of freedom that we did in the independent means t-test. So this is all these differences are going to accumulate, as you can see. So degrees of freedom, estimated standard error, we got step 2 done. Step 3, we have an alpha of 0.05. Step 4, we need to find that p-value. So again, that is based on the mean difference that we see right there. So very nicely, SPSS tells us where that difference came from. That's your mean difference right there. You take that mean difference, you divide it by your standard error of the mean. It'll give you that t statistic. That's the t statistic for your sample. We're dealing, though, with probabilities. And the probability, we find that right there on that significance two-tailed. So it is so small that all SPSS can put up is 0. So we're going to take SPSS at its word. That p-value is 0, 0, 0. However, that's the two-tailed p-value. So we're going to have to take those zeros. We're going to have to divide it by 2. And we still get 0.000. All right. So now we have to make our decision. If the p-value is less than alpha, we accept the research hypothesis and we reject the null hypothesis. 0.000 is a lot less than 0.05. So in this case, we are going to reject that null hypothesis. If it was the other case, if the p-value was greater than alpha, we would accept the null hypothesis and reject the research hypothesis. So once again, there's your p-value, two-tailed SPSS, very nicely reminding you. Once again, we're doing a one-tailed, so we divide that by 2, go to our decision slides, and we decide that we reject the null hypothesis. So this is an example of why it is very, very important to choose the correct hypothesis test. Because for the exact same data, when we ran it as an independent means t-test, we accepted the null hypothesis. When we ran it as a dependent means test, we rejected the null hypothesis. So that exact same data led to 2 different conclusions depending upon the test that we ran. So this shows you why it's vitally important to choose the correct test. Because if the correct test is an independent means t-test, and you by mistake run a dependent means t-test, then when you should have accepted a null hypothesis, you might reject the hypothesis and vice versa. So it's very important, critically important, when we're dealing with the lives of people in our psychology experiments to make sure that we're getting to the correct conclusion, and we started off by running the correct test. All right, so in this case, we would conclude that people actually are better at remembering faces and they are remembering names. And this would kind of confirm that folk wisdom, that kind of common sense knowledge, that anecdotal evidence that we, most of us believe. All right, so that is it for what I wanted to cover today. So we got an exam coming up, so be aware of a little bit of weirdness to the due dates as we work up towards that exam. First thing that I want to let everybody know is that the due date to earn your mastery points for the chapters in exam number 3 is going to be April 8th by 11:59 p.m. So if you want to get 100% on your pre-test, if you haven't already, for chapters 6, 8, and 9, do those mastery points. I will take the maximum of your percentage of mastery points or your pre-test as your final score for the pre-test. But you have until April 8th at midnight, the day before the exam, to earn those mastery points. Excuse me. Homework assignment number 12, chapter 9. That is our final homework assignment pre-exam. That's due April 3rd at 11:59 p.m. And then just so that you're aware, the post-test is due a little bit earlier on Monday, April 8th. And this is just to give you enough time to finish the post-test, get that feedback, and use it to prepare for your exam number 3. So bear that in mind. I don't want anybody missing the post-test because you weren't aware of the due dates. This is in your syllabus. It's in my lab, and right now it's here in the test. So make sure that you complete that post-test in time. All right, so that is all that I wanted to cover for today. So we got some time for the practice time. So we got about 20 minutes left in the class. So if you're all done, if you're good to go, then feel free to call it an early day. But if you do want to see anything else, or if you want to start up on your practice, start up on your homework, go back and review some of the things. I'll be here for the next 20 minutes. Call me over if you need any help, and we'll start making sure that everybody is prepared to do absolutely wonderfully on exam number 3. Other than that, we're done for today.